Problem, a child is going to slide down a 3-meter long slide. That's the red part. That makes an angle of 65 degrees with the horizontal. We know there's a coefficient of friction between the child and the slide of 0.15. And we want to know how fast the kid is going at the bottom of the slide if the kid starts out with an initial speed of 0.3 meters per second. This is a conservation of energy problem. We know stuff about the child at the very top of the slide, and we want to find out things at the bottom. So I've got my conservation of energy equation, and now I'm going to cancel the things that don't belong. So initially, does the child have potential energy? Absolutely. They're at the top of the slide, so that's going to stay. Does the child have kinetic energy? Yes, because they are moving 0.3 meters per second. So nothing on the left side of this problem gets canceled. On the right, does the child have potential energy? No, because they are at the bottom of the slide, so that cancels. Are they moving? Absolutely. Definitely moving at the bottom of the slide. That's what we're trying to find at V. And is there thermal energy that was taken out during this problem? Is there friction? Yes, there was, because we know there was a coefficient. So that's going to stay as well. So we have a lot of things that stay in this problem, which is okay. What we're going to do now is write down the equations for potential energy and kinetic energy in our conservation equation. So potential energy is mgh, and actually I'll put mgh. M is orange for the kid being orange. G we'll write in green. And H in the picture right here is blue. So there we are. Then we have the kinetic energy, which is 1/2 times m times the initial speed, I'll call it v1 squared. On the right side, I've got kinetic energy over here, which is 1/2 m times the velocity at the bottom of the slide, I'll say that's v2 squared, plus the thermal energy, which is the energy taken out by friction, or the work done by friction, which is the force of friction, times the distance that the kid slides, which is d, that's 3-meter slide. Now normally we would start erasing things and plugging in numbers, which we can do, but we do have one problem, which is right here we do not know the h. If we tried to continue with this equation right here, we would find that we would know the g, we would know the initial v, we'd be able to get everything that we need except for this h. We don't have this h, so we've got to solve for this first, because we don't know the height. We know the length, but we don't know the height. So what we have to do is do a right triangle problem to solve for this h first, and then we can go back and finish with our conservation problem. So we have the hypotenuse, and we want the h. We have this 65-degree angle. So the h is the opposite side, so we're going to do the sine. And that would be that the sine of our angle 65 degrees is equal to the opposite side, h, over the hypotenuse, which is 3 meters. Now we're going to solve for h. I'm going to multiply the 3 over to the left. So sine of 65 degrees times 3 meters should give me the h that I need. And when I do that, I find that the h is 2.72 meters. So now I have the h here when I want to plug in. You might also find that, wait, I don't know what the force of friction is. We have the coefficient of friction, but we don't have the actual force of friction. So how is it that we would find that? I'm just going to show you where that comes from first before I start plugging it in to any equations down here. We've done ramp problems in the past when we talk about forces, so we know that the normal force of an object acting on a ramp is going to be equal to the force of gravity perpendicular, which we have that equation. That was the cosine of the angle times the mass of the object times 9.8. And here's what that looked like. If we're trying to find the force of friction, we know that's equal to the coefficient times the normal force. Well, we have the coefficient, which is 0.15. But now we need to know what is the normal force. Well, the normal force is the cosine of 65 times the mass times g, or 9.8. And this right here is just the force of gravity perpendicular, which is what the normal force is equal to when an object is on a ramp, like a sliding board. All right, so now we're ready to start plugging into our conservation of energy equation. Here we go. First things first, I have mass in almost every term. But if I look over here, if I plug in what I had for force of friction, I'm going to have mass there too. So here's what that's going to look like. On the left side, I'm still going to have my mgh. Plus my 1/2 mv squared. On the right side, I've got my 1/2 mv squared. And now when I get to my friction, I'm going to plug in what I have right here, which is 0.15 times the cosine of 65 degrees times mg. Now I can actually get rid of, oh, I almost forgot, got to keep the d as well. There we go. That would have been a mistake, but thankfully we caught it. And now we can get rid of these m's because I have an m in every single term. They all cancel out. And we are trying to solve for this velocity, this v2 squared. So I'm going to start doing that. I'm going to rewrite my left side where I've got gh plus 1/2 v squared. And since I'm trying to get v2 all by itself, I need to get rid of this term here. And since I'm adding it, I'm going to subtract what I've got right here. So I'm going to say minus 0.15 times the cosine of 65 degrees and then that's going to be multiplied by the acceleration due to gravity times the distance of the slide. And that's all going to equal 1/2 times v squared. For the sake of room, I'm not going to rewrite everything right here, sort of just follow along with the algebra. And if you notice, I'm trying to get rid of this 1/2, which I'm multiplying on the right side. So how do I get rid of something I'm multiplying by? I divide it. So I'm going to divide 1/2 over to this side. And now I'm left, that leaves me with v squared over here on the right. But I don't want v squared, I just want v. So how do I get rid of the squared? To get rid of the squared, I take the square root. So from here, we're just going to plug in the numbers and solve, and then we are done. I think I'm going to go to, see, maybe we can fit this all on this slide. Here, let's give it a try. So my G is 9.8. The H we solved earlier was 2.72. We've got the 1/2. Our initial speed was 0.3. And we're going to square that minus, or 0.15 times the cosine of our angle. Times G, which is 9.8, times the D, which was 3 meters. A lot of stuff there. And that's all going to get divided by that 1/2. And you take the square root, to find V2. A lot of stuff there to plug into our calculator. But once we plug all that into our calculator, we get a very easy answer, which is that the V at the bottom of the slide is simply 7 meters per second. Long problem, but that's the end.